Hi students, it is a pleasing welcome to all. Nice to hear that you are going well on studies. Best of luck. This is Gopal from Department of Chemistry, Bharathidhasanar Matriculation Higher Secondary School, Arakkonam. Today I am going to teach you 11th chemistry and first unit. Our today topic is stoichiometry. What is stoichiometry? It is nothing but the study of quantitative aspects of chemical reactions. So, our chemical reactions have a quantitative and qualitative aspects. To increase the qualitative aspects, we need to study about the rates or the concentrations that are also. But to find about the quantitative aspect, we need to know about stoichiometry. What is stoichiometry? Stoichiometry is used to the purpose of determine the quantitatives, the mass or the volume of the reactants and products involving in the chemical reactions. So, to find the quantitative aspects in the chemical reactions, we need a stoichiometry. So, stoichiometry is the process of balancing the chemical equations. Let us see here. The word stoichiometry is used in the measuring values in the thermometer or calorimeter. For example, the word stoichio, stoichio. What is the meaning for stoichio? Stoichion means it is an element and metron means it is the measurement. So, stoichion means element and metrons means measuring. So, measuring the elements in the chemical equation is the stoichiometry. By the stoichiometry, we can find the elements involving in the chemical reactions. Let us see here. By the stoichiometry only, we can find the quantity of reactants and products involving in the chemical reactions. So, the coefficient of substance that we needed and the coefficient of substance that are given can be solved by the particular ratio of stoichiometric equation. By the stoichiometric equation, we know the variations between the moles and number of particles involving in the reactions. If you know the mole, you can tell the number of particles present in the equations. The particles is 6.02 into 10 to the power of 23 particles. So, it is a mole concept, you know, and by the mole we can know the masses of elements, that is the molar mass of element. 1 mole mass of element is the molar mass. So, masses of the elements is obtained by the given mole and the number of particles involving in the reactions is obtained by given mole and the volume of the gaseous molecules also obtained by given mole. 1 mole of any gas molecules can have the volume 22.4 liter. So, by this means we can know how much of gas molecules involving in the reactions by the mole. So, this is the one of the method in stoichiometry. These calculations includes stoichiometric calculations. So, to calculate the number of elements present in the reactions, we need to know about stoichiometric calculations. The stoichiometric calculation includes the 3 steps. Step 1, balance the chemical equation if already is not done. So, you need to balance the equation first to identify the number of molecules involving in the reaction. So, first one is balance the chemical reaction and second step, determine the molecular ratio for the substance involving. So, the ratio of molecules or ratio of the moles involving in the reactions want to find, it is the second step. And our third step, multiply the given amount by the molar ratio. So, the given amount obtained you want to multiply by molar ratio to find the total number of moles involved in the reactions. So, total number of moles and total number of molecular mass is identified by multiplying the moles by the mass. This is the third step involved in the stoichiometric calculations. Let us see here students. Now, I show you one of the example reaction and how stoichiometry can be used in the reaction. Let us see the reaction. Hydrogen molecule reacts with oxygen to form water molecule. This is an example of simple reaction in which the number of hydrogen molecule involved in the reaction is 1. and the number of oxygen is 1 and number of water molecules also 1. So, the number 1 represents the moles involved in the reactions. It represents 1 mole of elements involving in the reactions. This is the mole number of the elements. So, our question is, how many moles of oxygen gas will react with 5 moles of hydrogen gas? So, I can change this reaction like this. Hydrogen reacts with oxygen to form water molecule. So, they changes the question as like the hydrogen reacts in the equation is 5 moles. So, when we write 5 moles of hydrogen here, we need to change the product also. So, 5 moles of H2 molecule can form 5 moles of water molecules. After we change the product, we need to change another reactant. So, 5 moles of oxygen gas is eliminated. That means 5 moles of oxygen single element is eliminated. So, single oxygen is 5 means we need to change the double oxygen also. So, if we write here the number 5, it will be changes into higher. If you write the number 5 means there are double oxygens. So, 5 into 2, 10 numbers of oxygen will be present in the right side, but we need only 5 oxygens. So, we can write 2.5, that means 5 by 2. So, when we take 5 by 2 moles of oxygen molecule, we can get 5 by 2 moles of oxygen gas will contains only 5 numbers of oxygen elements. So, that means 2.5 oxygen molecules can contain only 5 numbers of oxygen. So, 5 by 2 is the answer. So, 5 by 2 moles O2 molecule can be used in this reaction. So, our next question is, see this, how many moles of water will be produced from 7 moles of oxygen gas? So, we copy the reactions from this. The number of water molecules involved in the reaction is changed into 7. So, 7 numbers of H2O is going out means we need to take 7 numbers of hydrogen molecule. So, from the product we can change the reactant molecules number, and we can another change into another reactant molecules, that is 7 hydrogen molecules can react with 7 by 2 O2 molecules. Why? Because in this reaction the 7 hydrogen molecules can remove 7 water molecules, but 7 oxygen elements only removed in this reaction. So, product formed contains only 7 numbers of oxygen. When 7 by 2 numbers of double oxygen reacts in the reaction, we get only 7 numbers of oxygens in the reactant. So, 7 by 2 is the right answer. So, by the stoichiometry we can find the number of reactant molecules involved in the reaction. Let us see the another table. This table is given in your textbook, the stoichiometric calculations. By the stoichiometric calculations, we can find the number of moles and the molar mass and how much of molar mass for a particular mole. See this reaction. This reaction contains the methane CH4 reacts with oxygen to form carbon dioxide and water molecules. So, in this reaction, the reactants are given are methane and oxygen, and the products given are carbon dioxide and water molecule. Here, stoichiometric coefficients, that means the number of moles involved in the product and reactants is the stoichiometric coefficients. The reactants contains methane 1 mole and oxygen has 2 moles and carbon dioxide gas 1 mole, and water molecules can have 2 moles. So, this moles is the mole relationship. So, for the mole relationship we can write the number again. Stoichiometric coefficient is the mole relationship. When we see the mole and mass relationship, we need to multiply the moles into their respective mass. So, the respective mass of CH4, the carbon generally have 12 gram per mole and hydrogen gas 1 gram per mole. So, CH4 can have 12, 1, 1, 1 and 1. So, totally 16 gram and its mole is 1. So, 1 into 16 gram is the total mass present in the methane. And next one, oxygen. Our oxygen contains only oxygen element. The molar mass of oxygen element is 16 grams and our equation contains 2 moles of oxygen. So, 2 into 16 we have 32 grams. But here you need to listen one thing, that is our oxygen not a single element, it is a double element. So, it contains oxygen and another oxygen. So, we need to double times write the oxygen mass. So, 32 into 2 we can get 64 gram as the answer. And let me go to the products. What are the products given here? Samantha, you say, what are the products given here? One is carbon dioxide, another is water molecules, hydrate. Okay. What is the mass of carbon dioxide? At least you tell the individual mass of carbon and oxygen elements. For carbon 12, right. For oxygen 16, right. For carbon 12, for oxygen 16. Okay, the number of carbon present in this 1. Okay, the number of oxygens 2. Okay, so 2 into 16 32 and 1 12. 32 plus 12 44, right. So 44 gram. 44 gram is the mass for 1 mole of carbon dioxide. Use it. And Jitesh, you tell me how many moles of carbon dioxide given in the reaction? Yeah, single 1 mole. So 1 mole of carbon dioxide can have the same mass 44 gram as a total mass. Use it. And next one, Tenmoli. You tell what are the elements present in the water molecules? Hydrogen, another one oxygen. Okay. Tell me the mass of hydrogen and oxygen for single mole, 1 mole. For hydrogen 1, for oxygen 16. Good. Use it. So, the number of hydrogen present in this reaction is 2. So, total mass of hydrogen 2. And number of oxygen present in the reaction is 1. So, total mass of oxygen is 1. So, total mass of oxygen is 1 into 16. So, hydrogen can has 2 and oxygen has 16. So, totally it has 18 grams. For single mole, that means 1 mole of H2O can have 18 gram as a molar mass. But in our reaction, we have 2 hydrogen oxide, that is water molecules. So, 2 numbers of 18 gram we have. So, totally 18 into 18, 36 grams of water molecules present in the products. So, by the stoichiometry, we can find the number of moles involving in the reactions, and molar masses of elements can give the total masses of reactants and products in the reaction. So, how many reactant molecules we can take, how many product molecules will formed can easily be said by stoichiometry equations. So, this is the stoichiometry calculations. And another one point is, every gas molecules can have only 22.4 standard liter for a mole. 22.4 a standard liter for a mole. So, all the gaseous reaction, if it is taken in a mole, it will contain 22.4 liter, and see here we have only 1 mole of CO2, so it can have 22.4 liter, but here we have 2 moles of H2O, so here we have 44.8 liter as the volume. So, by the stoichiometry we can find mole masses and also the volume. So, we can find the volume also. This is the stoichiometric calculations. And students, in page number 15, the volume 1 chemistry book can have the calculations involving the stoichiometric method. So, stoichiometric calculations and problems are given in the page. You need to complete the questions by writing just, and the study materials, question bank and self-evaluation question paper also given in the description. You need to complete the below description self-evaluation test question paper and send us a photography for corrections. Thanks for making time to watching this video. Thank you.
Nalini Amurtha's father, PKG-லேருந்து 8th standard படிக்கிறாங்க. இப்போ அது 5:30 to 6:30 வந்து கிரவுண்ட் ரன்னிங் ப்ராக்டிஸ் பண்ணிட்டு பாடி எக்ஸசைஸ் பண்ணிட்டு அப்படியே ஸ்கூல் அட்டெண்ட் பண்ணிட்டு மத்தியானம் மேலே மதர் தெரேசா அகாடமிலையும் ப்ராக்டிஸ் பண்ணுறாங்க, மெட்ராஸில் MEMலும் ப்ராக்டிஸ் பண்ணுறாங்க. நேஷனல் லெவலில் வந்து கோல்டு அடிச்சிருக்காங்க.
நான் அரக்கோணம் பாரதாசனம் 6 வருஷமாக டேபிள் டென்னிஸ் கோச்சாக இருக்கேன். நிறைய ஸ்டடீஸ்லேயும் சரி, ஸ்போர்ட்ஸ்லேயும் சரி